like I said, we're going to continue working with distributive property, making sure that we really understand how to break apart these numbers and these equations. So I want you to think about what is distributive property. Think about this in your head for a second. Think part, whole. You know what part, whole is. I know you learned that in first and second grade. How is thinking about part, whole help you with distributive property? What is distributive property? I'm just going to keep going. So, distributive property is just a way to break apart large equations into smaller, easier ones. Just like if we had a big number and we wanted to break it apart into two smaller, easier numbers, we have our whole number and then two parts. We have our whole equation and we're breaking it into smaller, easier equations. Okay? So if I was doing part, whole, let's say I have the number 72. Ooh, that's a big number, kind of an odd number to work with, not very friendly to me. I might break it into 70 and 2. Does that make it a little friendlier? Yeah. You might break it into 35 and 37. You might break it into 60 and 12. Part, whole is breaking apart numbers. Distributive property is breaking apart equations. Okay? I want you to go ahead and write this in your notebook, please. Why would I use distributive property? Why would I even use it? I want to know. Why would I use distributive property? When would it be helpful? Why would I use it? Hayden?
Break apart, I think, numbers.
To break apart those numbers, make it a little easier.
Yeah.
I can't do 24 times 5 in my head, but I can break it apart, make it a little easier. Why else would I want to know distributive property? Why else would I want to do that? Bailey?
Because it's easier and it's not as quick as other strategies maybe, but you can it helps you understand the problem better since you're breaking it apart into smaller pieces. And for me, it's easier to understand smaller bits of information than just one whole piece.
It's definitely customizable. You can pick the numbers that you like.
And then it also helps if it's a big number, if there's a big equation or number, because you can break apart the big number that you might not know, and then you feel like you know, like you might say, oh, I can't do that because I don't know how to do that, but then you could break it apart and realize, oh, I can't do this because
Sure. Definitely helps make the problems much easier. Matthew?
it helps you understand the problem.
Yeah, because it's again breaking it down to something that's pretty easy for us to solve. The only other reason that I really like distributive property and I use it frequently is I like to use it to solve things in my head. I'm not going to solve 24 times 5 in my head just like 24 times 5. I'm going to use my distributive property skills to break it apart to make it a little easier for me. Because I didn't memorize my 24 facts. I do know my 5s. I know 5 times 4, and I can figure out 5 times 20. That makes it a lot easier for me. So we're going to use distributive property, as you know, in mental math, which we've been practicing. You you guys have been breaking apart equations in mental math for weeks now. And it does make it a little easier. So we're going to do this problem with, go ahead and write it in your notebook. Equation is 6 times 7 equals question mark. We're going to use distributive property. I don't care if you like to skip count right now. I don't care if you have it memorized right now. Right now we're practicing distributive property, so that's what I want you to do. After today, you can use whatever strategy you like. But today I want you to use distributive property. Yes?
There's something about how distributive property can help you.
Go for it.
It's adding on to numbers, but not really.
Okay.
So it's just saying it will take you a little bit to do it, but it could be helpful because you at least have, if you know this problem like well, say 5 plus, like 5 times 3, 15. If you have that, you know what it is, and then the next number, like 3, you have at least 50% to get it correctly.
Sure. Sure. It definitely sets you up to get lots more problems correct. Which number would you like to break apart? We have a 6 and we have a 7. Susanna. 6. Okay. Underline the 6. That's what we're doing right now. Susanna, what are we going to break apart this 6 into? Hopefully something easy. 3s and 3s? So we're going to double?
Yeah.
I like doubles. That's a little less work for me. So you should be writing with me. I'm writing, you're writing. We've broken up our 6 into 3 and 3. So now instead of 6 times 7, I have 3 times 7 plus another 3 times 7. Where did my 3's come from? One is here, and 1 is here. Notice my 7 stayed the same. I didn't break up my 7. I only broke up one number. Are you writing?
I'll do that.
What I've done? Got it all written down. Okay.
Can I go fill my
Nope.
phone?
Okay. Now we have to do some math. Gotta solve what's in those parentheses. What's 3 times 7? 3 times 7. Nah, that is a crutch. Don't use that. Use your brain. I know what you're looking for. Use your brain. Ooh, Matthew said, well, 2 times 7 is. That's a good place to start. Figure out 3 times 7. 3 times 7. 3 times 7 is 14. What's your place to start? 14. What is 3 times 7? Here.
21.
21. Susanna picked a nice number because what's 3 times 7?
21.
21. 21 plus 21 is, what you get? 42. Nicely done.
I got 2. I just added the 2 plus.
How many of you have your 6 times 7 memorized? Like 4 of you. How many of you got the right answer after we did distributive property? Should be all of you. Yeah. And we solve it a different way.
Yes.
Yes. Break apart a different factor. We broke apart the 6 first. So now I want you to break apart the 7 into a different way. Remember to use your favorite math facts. My favorites. 2s, 5s, and 10s. If your favorites include 3s or 4s, go for it. Those just aren't mine. Your brain, you solve it. So we have 6 times 7. This time we're breaking up the 7. Go ahead and do it in your notebook. it over a little bit. Don't do it here. Do it over here. You didn't solve it. It's 3 times 7. I didn't. So why'd you write 1 and then solve it over here the other way. I peeked at most of you and saw that you broke up that 7 into a 5 and a 2. Raise your hand if you did that. 5s and 2s, my favorite. I love some 5s and 2s. And then you were like, okay, well 5 times 7. No. 7's gone. All gone. It's now 5 and 2. Is 5 and 2 still equal to 7? Yes. But our 7 is gone. Gone. So my equation, instead of 5 times 7, is 5 times 6 plus
6 plus 2.
I heard
times
plus
7
in
times
there.
2 times 6.
Could I have written 6 times 2?
Yes. Because of
Why could I have done that?
Because of commutative property.
Which says,
You can do the fact that still get the same.
product is going to be the same. It does not matter the order of my factors. My product will remain the same. Yes. 5 times 6 plus 2 times 6. Let's do 5 times 6 first. What is 5 times 6? What's that product, Kaden? 30. Nicely done. Plus, what's the product of 2 times 6? Or 6 times 2, however you put it in your notebook. Edith? 12. Okay, now we have 30 plus 12. Right, I'm okay with you standing. I'm not okay with the back of your head facing me. Jake, what'd you get? 30 plus 12?
I did different factors.
Okay, well, we're working with 30 plus 12. Did you break apart the 7 or did you break apart the 6? Excuse me? Okay, well, we were both breaking up the 7 that time. We broke up the 6 first time. So 6 times 7 is 42. Question?
That's not a question. It's from both times we solved it, it has the same answer.
Both times we solved it and has the same answer. Why do you think that is? Because we did solve it different ways, did we not?
Yes.
Yeah. We broke up the 7 this time, but a little bit ago we broke up the 6. But yet we still got the same answer. Why do we think that happened? I tell you, you have the tools to know that answer. They are in your brain somewhere. Riley, why do we think that happened?
It's the same equation.
It's the same equation. There's a specific property that will tell you that. I bet you know it. I bet you just didn't know you know it. Riley, what are you thinking?
Commutative property.
It is the commutative property. I know normally we think of the commutative property as our factors moving, but it's also including, it doesn't matter what order you solve it in. So whether I break apart my 6 or my 7, the commutative property says it doesn't really matter which one you do, your product is going to remain the same. So that was a great observation. Matthew. You can notice that even though we did break up different numbers, our equation remained the same. Peter?
I thought we were actually going to add up this to the numbers.
Nope. we were done. Isn't that amazing?
Yep.